Okay, just a couple discussion questions here out of chapter 3. Beginning of chapter 3 is vectors, so we've already done some of those. But 27 through 30. Alright, so this is page 109, again, end of chapter 3. 27 says a dart is fired horizontally from a dart gun, and another dart is dropped simultaneously from the same height. If air resistance can be neglected, which dart hits the ground first? Alright, so you're firing the gun, dropping the bullet at the same time. This is the first sort of classical problem. The vertical information is all the same. The initial vertical velocity is 0. Gravity affects them both the same, so they hit at the same time. Yes, the one that's fired out of the gun ends up way over there, but they'll hit in the same amount of time. 28. If a rock is dropped from the top of a sailboat's mast, will it hit the deck at the same point whether the boat is at rest or in motion at constant velocity? Well, draw a little boat. Alright, so here's a little guy at the top of the mast. He's dropping, what is he dropping? A rock. If the boat is still, obviously, we're going to hit right there. But what if the boat is moving? Well, if the boat is moving to the right, does that mean the boat's going to sort of move out from underneath the ball, and the ball hit maybe over here? Or the rock? Well, you've got to consider that the guy and the rock and the mast and the ship are all moving together. So even though the ship is moving to the right, well, the ball is too. So they have the same horizontal information. So it would hit in the same exact spot. Yes, the ship seems like it's moving out from underneath it, but the ball is moving to the right too. The ball is going to have sort of this little half trajectory shape due to, what an observer on the ground would see, sort of this shape. Of course, the guy moving with the ship would just think it's falling straight down. But while the ball is moving to the right, the ship is also moving to the right, so it would hit the same spot. Alright, 29. Does a ball dropped out of the window of a moving car take longer to reach the ground than one dropped at the same height from a car at rest? Alright, that's the same question as firing the gun, dropping the bullet. Okay, just because one has horizontal motion doesn't mean their vertical information is any different. So it would take the same amount of time. Okay, and then 30, a rock is dropped at the same instant that a ball at the same elevation is thrown horizontally. Which will have the greater speed when it reaches the ground? Okay, so we have one ball falls, one ball is shot horizontally off this little cliff. Which is going to have the greater speed when it hits the ground? That's a good question. They will both have the same vertical speed when they hit the ground. At this moment, vertical velocity straight down, vertical velocity straight down for that other ball. But the one that's fired horizontally also has a horizontal component. So overall, the speed of the ball that's shot horizontally has to be greater. Vertical velocities are the same, but it didn't say specifically vertically. It just said which one will have the greater speed. So the one that's fired horizontally will have the greater speed. Okay.